All right, what's up, guys? I'll try to go fast through this. All right, these ones, hopefully we did in class. Let's see. 3, 5 is right. 1, 2, 3, 4, 5. 3, 5 is there. 0, 4 is there. And -2, -2 is there. So we've got this triangle. If we dilate it by a factor of 2, we're going to make everything twice as far from the center as we can. So basically, we just multiply everything by 2. So 6, 10, I'm assuming is like over here. 0, 4 goes to 0, 8, because we're multiplying by things by 2. 5, 6, 7, 8. And -2, -2 is now at -4, -4. So this would move from there to there. We just dilated it by 2. I would label them. Let's see, where's 3, 0? This was B. That was A. This is C. So now we're at A prime, B prime, C prime. All right, over here, we're gonna make everything 1/4 the size. So we're gonna make everything 4 times closer to the middle. We're gonna divide by 4, basically. So 0, -4 would be right here. If I divide both of those coordinates by 4, I'd be at 0, -1. So J was here, J prime was there. I just divided both of these by both of this, 0 and -1. I divided them both by 4 because basically I multiplied by 1/4 is the same thing as dividing by 4. So 0, 6 goes to, 6 divided by 4 is 1.5. This one will go to 1, 1. This one will go to 1, 0.5 because I'm just going to multiply them all the numbers by 1/4, or basically just divide by 4. So you can graph those, all of those, and you get like a big shape and you get a small shape in the middle. All right, we're not going to go about the vertex. We're going to go about the origin. So basically for this one, I'm going to do 1 point for you, and you can do the next. 3, -1 is right here. 3, -1. And this is down in the Doty neighborhood, right? The positive negative neighborhood, area 4. All right, we're gonna go 270 degrees counterclockwise. So that's 90, and we're going the opposite way as a clock. 90, 180, 270. So we're gonna end up down in Sussman's neighborhood where everything is negative. Every time we move one neighborhood, we flip it back and forth. So we were at 3, -1 over here. Once we flip one neighborhood right here, we go to 1, 3, then back to 3, -1, now to 1, 3 again. But we need to make them both negative because they're in the Sussman neighborhood. So we're at -1, -3. There's -1, -3. So you're going to do that with every point. You're going to do that with 5, -4, and 1, -5. All right, for this one, you're going to do the same thing. So you're going to start with the same point, 3, -1. And you're only going to go 2 neighborhoods. So 180 degrees is 2 neighborhoods. So we're going to go 1, 2 neighborhoods. So we're going to end up over in Stauffer's neighborhood. So over there, if I flip twice, I flip it from 3, 1. And I flip it backwards to 1, 3, but then I flip it back to 3, 1. So it's going to be 3 and a 1, which puts me right there. But if 3 and a 1 are in Stauffer's neighborhood, then the first one is -3, +1. And you'll do that with all 3 points of that triangle. This point, and this point. Let's see, 8. Okay, so number 8. If, like, let's say I have these points, right? -5, 3, which is -5, 3 right there. You can make your graph however you want. -4, -2, and, -2. Sorry. -4, -2, and -2, +3. There's a triangle right there. If I flip this over the y-axis, I need to know the shortcut. I could count spaces to the y-axis, which is this line right here. I'm going to use that as the mirror. But if I'm using the y-axis as the mirror, I just go through and switch all the x's. I switch the other ones. So instead of -5, 3, I have 5, 3, and 4, 2, and 2, 3. And if I graph those spots, 5, 3, 4, -2, 4, -2, and 2, 3. And there's where my triangle, there's where it flips to. Do the same thing over here. If I'm flipping over the y-axis, I'm just going to switch the x. So I'm going to graph this normally, and then I'm going to switch that one, that one, that one, and that one to negative or positive. Like just flip it. And I think this one you get like some sort of a shape that like kind of crosses over itself. It's like something like that, and then it's going to be something like this. So I forget what the shape is, but it's something like that. Okay, let's see. Number 10. If I start with this spot, -1, -4, and I do a reflection and I end up with -1, -4, it's asking, did I reflect over the y-axis or the x-axis? Well, I see that the x's stayed the same, so no change there, but I see the y's changed. The y flipped. So if I flip my y variable, I must have reflected over the x-axis. It's always the opposite one that you think. All right, over here, the y's stayed the same, but the x's changed. So if the x is changed, I must have flipped over the y-axis. Okay, a graphic designer created a logo that's 8.5 by 11, so we can say 8.5 by 11. And now we want to get it to go to 1.7 by 2.2, 2 1/5. Okay, anyway, we basically have to multiply our big paper by something, we'll call it K, to shrink it down to our small paper. So what are we multiplying our big paper by to get to our small paper? Well, our big paper has a side of 8.5. So if we multiply that by something, it shrinks it down to 1.7. So we can say 8.5 times something times K equals 1.7. And we want to figure out what is that something that we have to multiply by. So let's divide by 8.5 to get rid of it over here. And it turns out K was 1.7 divided by 8.5, which is 0.2. So our scale factor was 0.2, so which is 1/5. So basically you had to shrink everything but 5 times or multiply by 0.2. This one was tough. He's got plans for a pool, once you read this, that are 18 by 36 inches. So we have 36 inches long, but that's how big his plans for a pool are. But the pool is going to end up being 9 feet wide, which when we do 9 times there's 12 inches in a foot is 108 inches. So we have to multiply our plans by something to grow it up to 108. So 36 times something grows us up to real life. So we divide by 36, and it turns out our real life needs to be 3 times bigger than our plans. All right, A, I did in class. For a lot of people, I'll go. That one's gonna be a long video. Maybe I'll make a different video for that. For these, you have to know all the shortcuts. Like if I reflect over the x-axis, then I change the y. So this must be to -3. If I dilate, that means I'm multiplying. So 2, 3 turns into 6, 4. Multiply. If I rotate 90 degrees clockwise, I got to say, okay, let's see. 7, 6 is in Griffith's neighborhood, but if I move once, I have to switch the numbers backwards. Now, if I'm going clockwise, that puts me in Doty's neighborhood underneath us, so that's positive, negative. All right, so let's see, 8, -4. In that 8, -4, I would be down in the bottom right in Doty's neighborhood. If I go 180 degrees, that's 2 neighborhoods. Now I'll be in the upper left. That's Stauffer's. And when you rotate 2 neighborhoods, you switch front to back, but then back to front. So you switch back to normal. So these are going to be 8 and 4, but to be in Stauffer's neighborhood, I would have to be negative. I'd have to go backwards and then up. So it's -8, +4. All right, see if you can go through these. Maybe the hardest one is this one. 12-2, I'm in Griffith's neighborhood, station number 1. If I go 270 degrees counterclockwise, that's 3 neighborhoods backwards, 3 neighborhoods left. So I've moved back to Stauffer's neighborhood, I moved down to Sussman's neighborhood, and I keep going over to Doty's neighborhood. So now I'm in Doty's neighborhood. I move 3 times, so that's backwards, regular, backwards. So I'm at 2, 12. And now I gotta say, okay, Doty's neighborhood always has a positive first one and a negative second one. So 2, negative 12. Let's see. Translation, translated 4 left and 3 up. I know 4 left means I move backwards by 4, so I'll take away 4 from my x. And 3 up means I'm moving my y up by 3, so I'll add 3 to there. So I get negative 11, negative 4. Let's see. Rotated, what's another one I can do? Dilated by 1/2. So I just multiply both of those things by 1/2. Rotated 90 degrees counterclockwise. Okay, so if I was in, for 18, 2, negative 4. 2, negative 4 puts me down here. So I'm in Doty's neighborhood. I'm going to go counterclockwise, which is this way, up to Griffiths' neighborhood. So I'm going to be all positive. So I'm going to switch the numbers back and forth because I'm rotating one neighborhood, and I'm going to Griffiths' neighborhood, so I know they both have to be positive. All right, that's a lot of help. See if you guys can, I'll try to do number 5 on a different video, but for now, good luck.